Okay, here we are in part 3 of section 9.1. So this is the elimination method, or sometimes known as the addition method. I'm going to call it the elimination because you're eliminating one of the variables, and other people call it addition because you're adding two equations together and then eliminating one of the variables. So what we're going to do is we're going to write both equations with the x and y variables on the left side and the constant on the right. So sometimes, we might have something like x plus 2 equals negative 4y. And what we have to do is we have to get it all on the same side. So we'll have x plus 4y equals negative 2. So we have to get all of them on this side and all the constants on this side for both equations. Then we're going to use some multiplication factor to get either the x or the y variable to be such that when we add the two equations together, hence the adding, the two equations cancel, hence the elimination. And so what that means is, say we had maybe a 2x plus 3y equals 4, and maybe we had then an x minus 4y equals 3. Okay, well, what that means is we're going to multiply one of these equations together or by a factor, so when we add, they eliminate. And if I take this equation times a negative 2, then I'm going to have 2x plus 3y equals 4, and here I'm going to have a negative 2x, then plus 8y equals negative 6. And notice, when we add those two together, they cancel, and all we're left with is the y's. And so that's kind of the thing here. We're eliminating the x's, hence elimination, but when we add them, we get rid of the x's, hence the addition. So after we add the two equations together, then we're going to solve for the remaining variable. And then after we get that, we do what we've been doing. We substitute that value back into one of the original equations, solve for the other variable, and we get an xy ordered pair out. And then we're going to check that ordered pair in both original equations to verify our solution is correct. Okay, so let's look at this one. All right, so here we have 6x minus 5y equals negative 34 and 2x plus 6y equals 4. What can we do here? Well, I see that if I take this second equation times the negative 3, I'll get a negative 6 here, and then I'll have a plus 6, and that means that's going to cancel. So I'm going to take this times a negative 3. Now, what else could we do? Well, we could have taken this equation times 6, this equation times 5, and we could have eliminated the y's, and then we would solve for x, and then we could go back in and substitute back in and solve for y. But then when we multiply 34 times 6, we're getting to big numbers again. So we kind of try to eliminate as big a numbers as possible. And so that's kind of what I'm doing here. So 6x minus 5y equals negative 34. And when I multiply by negative 3, I have a negative 6x. And then I have a minus 18y. And then I have a minus 12. So, like I said, those cancel. And when I do that, then I have minus 18 minus 5, so that's a minus 23y equals minus 46. Divide by negative 23. Divide by negative 23. So y equals a positive 2. Okay. Now I can plug that back into one of these. I'll plug it into the second one just because they're smaller numbers. And so that's my y. And if I plug it into 2x plus 6 times 2 equals 4, then I have 2x plus 12 equals 4. Subtract 12. 2x equals minus 12 plus 4 is minus 8. Divide by 2. X equals a minus 4. Okay, so my ordered pair I'm saying is a minus 4 comma 2. So that's what my check has to be on. So now I do the check. And so I'll have 6 times minus 4 minus 5 times 2 equals minus 34. And I also have a 2 times negative 4 plus 6 times 2, and that's supposed to equal 4. Well, this is minus 24 minus 10 equals minus 34. Well, minus 34 equals minus 34. So it checks in the first equation. Now here we have minus 8, and then we have plus 12 equals 4. Well, 12 minus 8 is 4. and so it checks there. So that is my solution to this system of equations. And again, the check always should tell you if you do have it right or not. And so I highly suggest you try that on all of them. Now, like I said, if you have a no solution or an infinite solution, it's not as nice. But for the ones that you actually do get a solution, you'll know for sure one way or the other. Now, what do we do if we have these nice looking fractions? Everybody loves fractions. Well, I'm going to suggest we get rid of fractions. And once we get to other questions, we'll have probably some decimals. And I say get rid of decimals as well. And to do that, what we're going to do is first, we're going to multiply each equation by the LCD for that equation. So if we look at this, we have a 3, a 9, and a 9. What's the least common denominator there? Well, if we think about that, the least common denominator would be a 9. Here we have a 2, a 5, and a 3. So that means we have to multiply all those together. So 2 times 5 is 10, times 3 is 30. So here we have to multiply by 30. Okay. Now that's not too bad still. I mean, we just are multiplying, 3 pieces by the 9 and 3 pieces by the 30. So on the first one, we'll take 9 times that, and 3 goes into 9, 3. So that will give us 3x. 9 cancels 9, so we have plus y equals, and the 9's cancel, and we have just 2. Okay, so that turns into a nice equation from this one. Now these are equivalent, and so that's why we can do that. Now if we take 30 times this, well, 2 will go into 30, 15, so we have a minus 15x. 5 will go into 30, we have 6, so 6 times 4 is 24, so it'll be plus 24y. And 3 will go into that 10, so that equals a negative 10. All right. So now we've got our two equations, and we're trying to eliminate. So what do I want to eliminate? Well, I could multiply this one by a negative 24, and we can eliminate y's. Or I could just multiply this one by a 5, which is a lot smaller, and then we could eliminate the x's. So when we do that, 3 times 5 is 15x. 1 times 5 is 5, so that's 5y, and that equals 10. And then I have a minus 15x plus 24y equals negative 10. Well, guess what? Those cancel. So here I have 5 plus that's going to be 29y equals 0. Now notice we can still solve for y. So this is not no solution because we still have a variable here. It's when we have, if we would have had 29 equals 0, then it would be no solution. But we have 29y equals 0. So if we divide by 29, we get y equals 0. So that is part of the solution. Now we can plug that back into one of the original equations. So this time I would suggest we do just in case. So then we have 1/3 x plus 1/9 times 0 equals 2/9. Well, this is gone. So we get 1/3 x equals 2/9 multiplied by 3 over 1, multiplied by 3 over 1. Well, that goes in here once, it goes in here 3 times. So we get x equals 2/3. Okay, so we get the 2/3 comma 0 as our solution to this equation. Now we have to check, does it work? All right, so now if we remember, when we plug in 0 for y, basically those middle terms are just going to be gone. And so all we really have to do is take the 1/3 times 2/3 and negative 1/2 times x, and we see if we get what's on the other side. So we take 1/3 times 2/3, and that's supposed to be equal to 2/9. Well, that's going to be 2, that's going to be 9. So that one works. Because again, 0 times anything is 0, so those are gone. So we don't have to worry about that middle term, which is really nice in this case. And here we have a minus 1/2 times the 2/3, and that's supposed to be equal to a negative 1/3. Well, those cancel, and we get a negative 1/3 equals negative 1/3. It works there, so that is our solution. Okay. So, even though it started with fractions, ended with fractions, the checks are not bad, the work is not that hard, and we can get our answer pretty easily. All right, what about this one? So this one we have to think. Do I want to go from 7, multiply something by that to get 28, or do I want to take 6 times something to get 24? Well, 6 times 4 is 24, and it's the opposite sign, so I'm just going to take the first equation times 4. Well, 4 times 7, well, that's 28x. Guess what? That's 28x too, but a negative. plus 24y equals 8. Then down here I have a negative 28x minus 24y equals negative 8. So what do I get? Well, everything cancels. That's gone, that's gone, that's gone. So I get 0 equals 0. Well, what does that say? Well, 0 equals 0 is true. And so there's going to be infinite solutions because those equations are exactly the same. And now what we need to do is we actually have to solve one of these for y. I would suggest the first one. And so I would say 7x plus 6y equals 2. Subtract our 7x. So 6y equals negative 7x plus 2. Now we divide everything by 6. And so y equals negative 7 over 6x plus, and those cancel down to 1/3. Now, the reason why we're doing this is because we're going to write that general form. We're going to say, well, if we plug in x, then our y is going to be negative 7 over 6x plus 1/3. And so that would be our quote xy ordered pair based on those two equations. Because if you think about it, if you solve this one for y as well, you're going to get that exact same equation. Okay. Okay, so this one we actually have decimals. So what I'm going to suggest is get rid of the decimals in that first equation. Now the second equation doesn't have any decimals, so we can just leave it alone for now. And so how do we get rid of decimals? Well, these are all 1/10. So it'll be 1/10, 2/10, 6/10. And so if I multiply by 10, that moves the decimal right one place. And so if I do that, that's going to give me a negative 1x, or just negative x. And then it's going to be plus 2y equals 6. And then here I have 5x minus 10y equals 1. All right, now we have to think about, do we want to get rid of those y's or do you want to get rid of the x's? Well, let's get rid of the x's because I can see that we have opposite signs. So I'll just multiply that one by 5. So I have a negative 5x plus 10y equals 30. And guess what? What if I multiply that by 5? Those are opposites too, so it really doesn't matter. And so then we get that's equal to 1. Well, that cancels that cancels that. So I get 0 equals 31. Well, that's a false statement, so that means there's no solution to this one. And so that's one where we have no solution. It's inconsistent, and so we don't have anything as far as a check or anything. It's just we don't get a solution. Basically what that means was, they both have the same slope but just different intercepts. All right, so that's the end of part 3. I'll come back with part 4.